Hi everyone. So today we are to discuss about the ant colony optimization technique. It's one of the optimization technique. So with the help of the ant, okay, how it will be reach the food to their destination. Okay, how this ant it will be identify the food. Okay, so in the shortest path. Okay, so based on that concept. Okay, so one of the optimization technique was developed. That's why it is called as ant colony optimization techniques. So based on the behavior of the ant, this optimization technique was developed. Okay. So it's a generally this ant colony optimization that is used for the traveling salesman problem. Okay, like nowadays for the Zomato, Swiggy. Okay, for other ways for its Amazon. Okay, the salesman that hand over the product to the customer. Okay, so from one place to another place the salesman will be moved. Okay, so they have to with the shortest period how the work is going to complete. Okay, so normally this ant colony optimization techniques that is used for the traveling salesman problem. Okay, so see here for example for the traveling salesman problem. Okay, so he's traveled to some places. The places generally are mentioned here: place A, place B, place C, place D, and place E. Okay, the 5 places will be considered. Okay, so this salesman, okay, they have to move from one place to another place. Okay, for example, the salesman is in the position of A. Okay, okay, like in the area of A, he is in A area. Okay, and he is going to travel to the C means. Okay, how are to travel? Okay, there are two ways there. There is many ways there. Through to A to C directly he is moving, and through A to B and B to C he is moving. Okay, or otherwise from A, E, D and C. It is also it's another one possibilities. On for next one for it's A to D and D to C. These are the number of probabilities to reach the destination C. Okay, A to C. So this salesman problem, so they have to identify which path is the shortest path. Okay, here the here 75, 100, 175. That is it's nothing but kilometer. Okay, from area A to C. Okay, directly move from A to C means so the distance is 175 kilometer. Okay, via B, the area B at reach the C means what about the distance? So it's how A to B is 100, B to C is in 50, 150. Okay, so which one is the shortest path? Or this way, A to D, D to C means that is total distance is 200. Okay, A to E, E to D, D to C means okay, 75 plus 50, 125 plus 100. Okay, 225. Okay, so comparatively, which one is the shortest path? Okay, the salesman he's moved from A to B, B to C. Okay, that is for it's only for 150 kilometers. So that is the shortest path. Okay, so based on this ant behavior, okay, here the salesman also okay either he is maybe from the Zomato or in Swiggy or in Amazon or in Flipkart. Okay, so they have to sell their or they hand over their product to the customer. Okay, so easily they have to identify the shortest path. Then only so he will be complete the total target within a day. Okay, so this is the concept of the ant colony optimization. Okay, so what are the algorithm steps we are going to follow for the traveling salesman problem? Okay, first we have to initialize the parameters. Okay, and then you have to initialize the matrix. Okay, so for the pheromone levels and all. Okay, and the distance matrix also. Okay, you have to prepare. These are the first step. Okay, second step, construct solutions. Okay, each ant starts from a randomly selected city. Okay, first construct the solution. Either the salesman have to move from A to C, or have to move from A to B, B to C, or have to move from A to D, D to C. Okay, likewise. Okay, so the construct the solution. Okay, so by using these two factors, pheromone level and heuristic information. Okay, so they have to identify the probability. Okay, so what all the probability is there to reach the one area to another in the area. Okay, by using this formula, okay, I have to write the calculate the probability value. Okay, Pij I have to calculate. Okay, so then evaluate the tours. Okay, now each ant completes a tour. Okay, visit all the sites and return to the starting city. Okay, then calculate the total length of each unit tour. Okay, so finally for the next step, last step is nothing but update the pheromones. Okay, so finally, so we have to calculate the that is for it's a reduced pheromone levels. Okay, so the shortest path you have to identify. Okay, so and then so that iteration or in stopping criteria. Okay, I have to repeat this step 2 to 4. Okay, once it is completed, so from the starting point, next after reaching the particular destination, that is considered as a starting point. Okay, so from the that area, so they have to identify the next area. Okay, so what you are going to do, I have to repeat this step 2 to 4. Okay, for the set number of iterations. Okay, so this is the concept of the ant colony optimization. Okay, thank you.